Thank you for that wonderful introduction. And yeah, let's proceed. So, hi everyone. I am Soumya, and I'm currently working as a software engineer at Microsoft and working on Microsoft Teams. How many of you have used Teams before? Quick raise of hands. Yeah, almost everyone. Nice to hear that. Before beginning the talk, I would like to thank the organizer of this talk, Kiran. Quick clap of hands for him. I remember when I was an intern, at some random company, from that time itself, he was organizing the React meetups without fail. Every month he used to organize, one or two meetups. Till now also, whenever I have time, I, attend those. So yeah, thank you for giving the opportunity. And, anyone who hasn't joined, we already are a team of around 26,000 members. You can scan this QR code and, join the group. Okay. Now coming to the talk. So I am here to talk about web workers. Okay. Basically the talk was how to use web workers for fun and profit. Before learning about how to use web workers, let us actually learn why do we need them, right? We have JavaScript, why do we actually need them? And do we actually need them? Let us see that. Okay, how many of you know that JavaScript is single-threaded? Raise of hands. Okay, and what is the meaning of that? Very simple, right? JavaScript has a single main thread or UI thread, and it can execute only one task at a time. Okay, very simple. But you might ask me, how does asynchronous code like API calls, callback, etc. work, right? Like when you make an API call, nothing is blocked, right? It is not that your UI is frozen. You are able to click buttons, you are able to do stuff while you are fetching data and so on, right? This, something called event loop. This, who all know about event loop, right? You guys, everyone knows. We'll have a quick refresher of event loop so that you can fully appreciate web workers, okay? So we have this code. I want you guys to think of the output, on your mind, what will be the output here. And let us see what all things we have, okay. So first of all, we have the call stack, right? Here the code comes and executes synchronously line by line. We have the task queue where it holds the callback functions from, web APIs like set interval, set timeout, and so on. We have micro task queue, which holds the higher priority callbacks, like, from micro task, queue micro task or promise.then, etc. We have the web API section as well. These are provided by the browser, which are not a part of JavaScript, like set timeout, set interval. Then we have the mighty event loop, right? It continuously checks and asks one question. Is the call stack empty? If yes, it pushes stuff from the task queue or the micro task queue to the call stack, right? And out of it, if both of them are full, right? For example, if task queue also has something and micro task queue also has something, it gives priority to the micro task queue. Okay, I think everyone knows this. We'll quickly go through the output, right? First of all, this console log start comes because it is a simple synchronous operation. It is quickly executed and popped out of the stack, and then we have start in the console, right? Very simple. Now comes the interesting part, right? Because set timeout is a web API, when this line of code is executed, the set timeout function is pushed onto the call stack. Then it registers the callback function that it has, the set timeout, with the web API timer. Even though the delay is 0 milliseconds, it doesn't execute immediately, it waits there. Okay. Now the set timeout is done. We move on to the promise part. Okay. We have promise.resolve, which resolves immediately, and the dot then method that you can see here, right? It schedules the callback inside it, okay? And it is to be executed when the promise settles. This promise callbacks will go to the micro task queue. The micro task queue, as you know, has a higher priority than the task queue, which we'll see in, in some time. We have another synchronous operation, very simple. It will go to the call stack, it will execute, and now end is printed. Now, because the timer was of 0 milliseconds, right? The callback, the set timeout callback has already moved to the task queue. And now we have the magical moment. The call stack is empty. When the call stack is empty, what happens? The event loop kicks in. It asks the simple question, is the call stack empty, right? And answer is yes. So out of the task queue and micro task queue, it picks the one from the micro task queue, right? Then this callback of the promise is pushed onto the call stack. It has a console log and which is printed in the console, right? Again, it is empty. It again asks the question. Answer is yes. The callback from the set timeout is moved onto the call stack. We have the console log there, and we have that. Okay. That was stressful. How many of you had the answer right? Start, end, promise, resolved, and set timeout, callback. Okay, cool. Okay, now the main learning that I wanted to derive from here is asynchronous code only runs when the call stack is free or empty, right? Asynchronous code is only pushed from the task queue or the micro task queue only when the call stack is empty. But the catch is, what if the call stack never becomes empty, right? What if it stays busy? Okay, what happens then? Okay, this is what happens, right? The loading spinner of death. You might have already, encountered it some, whenever you are working in a professional life or in a personal life. You start getting user tickets, right? The users are saying the app becomes unresponsive. I can't even scroll when the report is generating. I thought the website crashed, man. The page is taking forever to load the next section. These are two painful statements for a web developer to hear. Who all agree, right? These are too painful, right? And there are a lot of studies, done by various institutions which say that users do not want slow websites. And today's day and age, with AI and everything, I can confidently say that having no website is much better than having a slow website. Okay. So let us look at this problem by having some code, right? The situation where the call stack stays busy. Let us try to create a scenario. Okay, we'll move to React. I have a very simple application, component here. So we have a set timeout, not a set timeout, a state variable called count. We have an answer. Then we have a calculate heavy sum function. I'm basically, looping over some 500 million, I think, times, and it is doing some heavy task. Okay, think of it like that. Then we have some render stuff, right? We are rendering the answer variable, count variable. We have a button called +1. When we click on that, the counter should increase. And then we have a get answer button. And when we click on that, the calculate heavy function, the calculate heavy sum function will be executed. Okay. Let us see what happens. Okay. So as you can see, I click on the +1 button and everything is working fine and dandy. The count is increasing, right? Fine. Now watch what happens, when I click on the get answer button. Okay. So I clicked on the get answer button and I'm trying to click the +1 button. Nothing is nothing is working. The UI was frozen for some time. Then we get the answer, whatever big number, because I, calculate this sum to 500 million, right? This we do not want, right? You might be thinking, why is this happening? Right? Very simple. The call stack was busy. Okay. The issue here was the calculate heavy sum function, right? You remember this one? So here, whenever we are clicking on the get answer button, the on-click handler triggers the calculate heavy sum function, and this function, along with its 500 million loop iterations, start executing. And our, the set time, the set count callback doesn't get time, to come to the call stack, because the call stack was empty. The call stack was busy with the calculate heavy sum function to complete. Okay. Let us try to fix it. Okay. Can web workers help here? Right? This is the talk on web workers. See, my mantra in life is never believe to blindly jump into any technology without using it. Right? As we say in Hindi, पहले इस्तेमाल करें, फिर विश्वास करें. Right? So let us see. So as you have seen already, the issue was occurring because JavaScript is a single-threaded language. It only has a single thread. So what if we had multiple threads? You can think of it, keep a mental model like, web workers are adding new threads to JavaScript. Okay? Let us see them in action. So this was the original code, app.js code that we already have. Okay. Let us remove the problematic code. Okay. We have completely removed it. Instead, I'll just add a use effect. Okay. Inside it, we are creating a new worker object. Okay. We use new worker and we are passing a path called worker.js. We'll create that in a second. Then we are storing that worker in a, instance, the worker instance in a state variable called worker, and we are doing set worker so that it can be used later on. Okay. Then we come to the worker.js file. This is a new file that we'll create. Inside it, we have an onMessage function. Okay. So you have to understand the main thread is running separately and the worker thread is running separately. Okay. So in order to communicate between them, they use messages. Okay. So this onMessage method will be executed. It is basically listening for any message which is coming from the main thread, right? It is listening continuously. So inside that, we are listening and we are checking the data inside the message event that I am getting from the main thread. Is it start? Okay, I'm just given a string called start. You can give anything. If it is start, then we start calculating the heavy sum that we're doing earlier, right? This is the exact same code that I pasted. We have essentially moved everything, that the heavy part from the main thread to the worker thread, right? We have offloaded that. Okay, and yeah, after the calculation, we can see we are posting the message. Like we have a post message function. Basically, it sends it back to the place that it was called, the place that was given the message, which is the main thread. Okay, then we come back to the app.js file. Right? Here also we have a onMessage function, which basically listens to the messages sent by the web worker, right? And whenever the web worker sends us the sum, right? Remember, we have a post message, it sends us the sum. Whenever we get that, we simply use, use a set answer to keep it in the answer state variable. Okay, everything, clear till this? Everyone is with me? Yes or no? Quick raise of hands if everyone is with me. Okay, great to hear that. Okay, this is some cleanup code that I have. When the component unmounts, I'll just make the onMessage handler to be null and I'll terminate the worker. Okay. Now, we want that whenever the user clicks on the get answer button, we send a message to the worker saying that, start button, the start command should be sent, right? This is what I'm doing, right? So whenever, the get answer button is clicked, I'm doing worker.post message start. So basically I'm sending the start message to the web worker so that it, starts generating the computation, right? And it sends us back the answer. Here it was, right? Okay, now let us see what happens after we made these changes. Okay, so now +1 is increasing the value, but what if I click on get answer? Then now you can see our website is not hanging anymore, right? I'm able to see the output, and whenever the computation was over, it updated the answer variable, right? This is pretty cool. Yes or no, guys? Okay, so this was the whole code that we had, and now our website is super fast. We might get the 100 performance score that we always aim towards, right? Okay, so when should I reach for web workers, right? Whenever you have some heavy computational work that you can pass on to the web worker, right? For example, you are parsing large CSV files, you are doing some image or heavy video processing on the browser itself, right? You want to run some AI models locally, maybe, right? You want to run file compression on the browser. There is a very nice utility called Scoosh. Basically, you might have used some sites like I Love PDF and such sites which basically compress the files and all, right? So they upload the file to their server, and they claim that they don't store and all. But this website, right, Scoosh, it basically does everything on the browser itself locally. So what it does, the heavy image compression part, it offloads that to the web worker, right? So the performance is not affected in that way. Okay, next we have heavy third-party scripts like Google Analytics or something. You can upload that to the web worker. PartyTown is a good example of a solution. You can look into that if you're interested. Okay, so TLDR, you can remember, if it is CPU heavy and if it is causing UI jank for your users, consider offloading that to a web worker. Okay, and can I use web workers today? Answer is yes. All the modern web browsers, except maybe Opera Mini, who uses that. Yes, you can confidently use web workers today. Okay, there are some limitations which you should know, that directly you cannot access the DOM from web workers, and obviously for that reason you do not have access to the window object or document, and you cannot access various web APIs like USB, WebRTC, and web audio. Okay, you have to take care of that. Okay, who all know this guy? Yesterday he was all over the internet. Okay, so I would like to end this talk with a meme. So Soham Parekh juggling multiple jobs, our JavaScript plus web workers juggling multiple heavy tasks. Okay, with that I would like to end this talk. You can follow me on these links, and you can access this slide here. Thank you.